Good morning. Another fairly brief update on how my stumbling game development is going. Sorry, I've got a bit of a cold. My voice is a bit off. You'll have to bear with me. But I've made a couple of changes, and one I'm happy with, the other I might revisit. The first is I've added drawing triangles. I want to be able to put little indicators on things, and I could do this with a sprite, but when the entire pipeline is built around drawing triangles, it just seemed easier to plumb in drawing triangles. I mean, is that even interesting? We can go have a look. I think it's drawable. I've done it in the most just like simple and ham-fisted way. So what used to be drawable is now quad drawable. Triangle is now tri-drawable. And when we push drawables, they will go into a buffer. When they're processed into primitives, we just process them differently. So that's the first change. The second change I've made is I've added what I'm calling animations. Now, they're kind of really stupidly simple animations, but what I want is an indicator to show what is about to happen. So you have a thing that is going to happen. It shows an indicator so the player knows what's going on, and then the game state updates. And this change took me more thinking than I expected. I think I set out on it without a full picture in my head of how it was going to work. And it took me a while to realize that really what I'm doing is I'm splitting an action across multiple frames, and that does require sort of reworking our main loop. So if I do a click there, hang on, I've got the animation time set to 0. The thing to do is go downstairs. There you go. You see there's an indicator, and then he moves. Let me go and find. Where would it be? So one would be in playing view. There we go. So you can set the animation time to 0, and then it lets it go. There's a bit of mess in here that we can maybe talk about in a second. The other one would be in main. And we'll recompile. So yeah, I think the most interesting thing here is the rework to the main loop. So there you go. You see it's going, I want to move here, then it moves. I want to move here, and it moves. And I've added that teal highlighting to check something, because I've now also added that if you click far away, the player will do some minimally sensible pathfinding to that point. I haven't checked that the pathfinding. Sorry. I haven't checked that it's actually sensible. So it's just using my Dijkstra map and picking the first path it can find. So I think my checks go clockwise. So you see how like it tends to go left if you're heading up, and it'll tend to go right first as you're heading down. But you can see here, I think, for navigating corridors and things, it's quite good. There's a lot of tweaks that need doing. So like here, if I click there, I start clicking these once. Because you're in an animation, I'm blocking interaction, which isn't a great user experience. But to start, I also think I might have broken enemy interactions in this change. No, I haven't. Okay, there you go. So if I click, you see I get a red indicator. So it has access to the game state and the action information to know what kind of thing it is. And if I spawn a couple of rats and I wait just until they start acting, so you can see they wake up. Then one attacks me, the other attacks me, that one attacks me. Right, you can see that enemy turns are also pumped. So you can have multiple animations before it gives me control back. All reasonably working. Like I said, I think I've broken it, so if I do this, I'll move through the rat, which is upsetting. But you can see that the rat turns are interspersed in with my turns. So they kind of, the core thing I've been looking at and working on, I think, is working, which is that the kind of actor ordering. In terms of what that change is, could show you it in the code, but I think it's a bit of a mess. So I was thinking what I might do, I might just quickly sketch it out. So the old version that is simple, we start our main loop, and the first thing we do is we pump the actor queue. Spell queue, there you go. This here says if it is not the player, then it comes back and keeps pumping. If it is the player, break. Right, so this is a loop that's just running. And what it's doing is it gets the next actor from the actor queue, it processes their action, it gets the next actor of the actor queue, processes their action, it keeps going until we hit the player. The reason the player is interesting is that we need to wait for user input to know what the player's next action is. At that point, we process player input. Is that true? I guess we do, right? So as we go through the kind of immediate GUI code that does the drawing, it goes through and works out what's drawn where. That's also checking where the mouse is, checking whether the thing that it's currently over was hovered last frame, checking if it's been clicked. So that's the point at which we're processing player input, and it's inside those handlers that we would update the player state. We then draw the frame. So we show you the thing, right? And then we loop. So then this comes all the way back up, and it goes round and round. Very simple, very limiting though. So all of these interactions have to happen within a single frame. And that's, I think, the thing that took me a while. Like I say, maybe it's an embarrassing admission because this is not a complicated change, but this had me tied in knots for a little while. So you introduce a real-time timer for animations as well as a game timer for game time. And actions have both. I don't know. It did wind me up a little bit. But where we now land is that the first step is pump frames. For animation. So our animations, animation seems like a fancy highfalutin term for it, but the way I've written it at the minute, there can be a single animation or indicator essentially in progress at a time. And what we need to do is just hold you steady for a certain amount of time. So if I pull the code up so you can see this one, we get rid of this. Come back to main. We're in main. There we go. So if there is an animation in progress and the animation is not finished yet, like its timer is not run out, then just continue drawing frames. So can we see? How does that work? Yep, so if the animation is still in progress at this point, it won't do the next chunk, is how that works, but it will still draw down here. So maybe it didn't need to do that. I think it needs to do that because I want mousing over things to still show hovers, right? I don't want the player to be just kind of like shut out of the game. So if I start an animation, I can still exit, for example. I think the game is still running, so yeah, that's pretty funny. But so like, that works. That's because I'm still pumping frames. And doing mouse interaction, down where it does it. So maybe actually the right way to say this is we pump frames, meaning we don't process player or enemy actions while this is going. This then says if animation finishes. Then we have to handle an action. Which I think you can see simply. Right, if the animation finished, we handle the action. At that point, there is no animation in progress. And so we go into the next chunk, which is our process actors, which works very similarly to previously, except that we have to say, keep going. Keep going until we hit the player, as before, because we have to wait for input, or animation starts. And when an animation starts, we have to set animation state. It's animation and planned action state. Writing this out now. So if we look inside of this loop, what we have here is actor. We update the game state the same as it was before. If it's the player, we'll talk about that in a second. Else, we're handling enemy actors, and we reinsert them back into the queue if they're going to act again. An enemy AI that used to just update game state now returns you an action struct that describes what you want to do and how it was animated. Now, interestingly, that how it's animated literally is just about the time, right? The actual information about what the animation does is all just done in playing view, which is maybe bad. Oh, I don't know. But yeah, so this is the same as before. We then reinsert the actor, but what we've had to do is we've had to put the action into game state. If it's not animated, right, then we handle it immediately, and this allows for that many actions being processed within a frame. So I think the only thing doing it currently in the game is not visible. It's when you're not visible to enemies and they forget you. That's not animated. So 1,000 enemies could all forget you in a turn, and we wouldn't stutter you at all. You just see the next frame. If you are animated, we set this animation in progress to true, which tells the next frame that needs to pick up that is animated loop. And we set the timer. All right, so the important change that's happened here is action taking is now split into a kind of plan and execute phase. And sometimes we plan and then immediately execute, and sometimes we plan and then execute later. Then the player chunk is made slightly more complicated again, because I want, depending on what action you took before, to sometimes continue taking actions automatically and sometimes not. You can see me in here saying there's a bunch of stuff to do in here. But the basic thing works. So I've got a planned path that I've added to the game state. Well, I actually have a buffer and a count. I could probably do with a function to get the slice, but I haven't done that yet. I've done this very quickly and messily. When the player makes a move action, instead of it, what's the right way to say? When the player clicks on a grid tile, instead of it making a move action and just doing it straight away, what it's doing now is setting this path. So maybe the thing to do, if we go in here, there we go. So grid click is what you get when you click on a grid tile. And the first thing it does, it tries to look up a path. We'll talk about that in a second, because that's the one bit of this I am happy with. Or at least not upset about. If it gets a decent path, or a path that works, so that when it goes from the point that you clicked on, it can reach the player, then what am I looking at? Active entity is set, current action is set to a move action, and all this other stuff. With the move action is to the last place in your planned path. And if we come back to main, then what we say is if I've just acted and I have a planned path that has things left in it, immediately make me another move action, right? And click the animation in progress so that we process it on the next frame. One of the things I'm also to finish that discussion, else we set it to none. That none is then used as the sentinel to say I need to go and get user action. One thing I'm not happy about is you notice there's no way in the player chunk to process 0 frame actions. They're all animated. This is why I had these set to 0. Is that basically works, but not perfectly. So if I set these both to 0, the game still has a high frame rate. So if I click, you see it does update very quickly. I actually don't know how well this is going to get captured in compressed video. But if I do a longer one, you can see that blue flash is because it is still drawing everything we were seeing before. Well, ideally, what I would quite like is that the mouse hover should probably show you the path you're to take. You click, and if you don't get interrupted, you just appear there, right? It probably shouldn't do this jumpy thing where you see the flash. I haven't added that yet. I haven't worked that out yet. Which is why, even if this is 0, this has to be true, because if this isn't true, we never hit that handler in the animating loop. Which I admit is a bit of a mess. The path side of this, I think, is maybe slightly interesting. One thing to say is it is hacked in. I don't guarantee that this actually works sensibly. So it picks a valid path. It doesn't necessarily pick the valid path you would want. And because of the nature of a grid where all distances in diagonal and vertical and horizontal are all equivalent, which is what I've been doing. From A to B, you could go in a straight line, or you could zigzag massively, and it take the same distance. So, I mean, yeah, is what it is. But it minimally worked well enough for us to keep going. I think it can be tweaked later. What it's doing is we already have this to get you a candidate, or the set of candidate positions that move from one place toward the player. So we've got our Dijkstra map, and all that is a set of numbers. So let's use the grid tiles. Can I zoom in and make them big enough for this to work? Probably not. Pretend every 2 by 2 of these is a tile. If the player is here, then that has value 0. Everything that is accessible, so let's say maybe that's a wall and that's a wall, and maybe that's a wall. Everything else here gets a 1. Yeah, you make an example. It's interesting. And then we do another sweep through, and what we find is all of the places that are 2 away, right? So we've just got basically a thing that's cached to say how far away, how many steps away from the player is this tile. So if we come around all of this, you can see from here, you have 3s, and it keeps going. Boring to keep doing it. You can kind of see my point. Can't here, can you? Here, that because this is a 2, you can go this way or this way, and they're equivalent. Similarly, from this 2, when I say find a candidate position that moves me toward the player, what I mean is find a position that's 1 less than this. Well, there's 3. They're all equally valid, right? You can take any of these steps. So that's a longer term worry. But now what we do is, let's say you click on this tile. We need to route you from here to up here. Let me grab a different color. What we do is we find those candidate positions, which will get you this one and this one, and we just pick the first one we find. So we'll take this one. We then look at its candidate positions, which will get you this one. And we then look and we find here. We go, okay, cool, we've got this. So we then have a planned path that is, I do like this. I've got a buffer with positions in it. So let's pretend it was 1, 2, 3, 4, 5, 6 long. I think in reality it's set by grid dimensions. When we look, the first thing we find is this 3 position. So we write that 3 position onto our planned path. The next one we find is that number 2 position there, and then the number 1 position there. And then we don't write any of these, and we set the count to 3. All right. So we know there are 3 tiles on our path. When we look to move, we take the last one, and then we essentially pop it, right? We set count is now 2, and it means that we can update like very easily what our path needs to do without having to touch this memory. Like that position 1 can just be left sat there, and this sort of count drops us down as we go further and further as we take steps. Count gets 1. When count hits 0, you've arrived from here at your destination, right? And then we're finished, and we need to stop automatically acting. Life is easy. I thought that was fairly neat and like fast, right? Because I think when I first wrote it, my first inclination was to do it so, I guess, to do the same sketch. You'd have them the other way around, right? You would do this, and then either what you need to have is like a pointer into the thing that moves up, but then you also need a separate thing to remember how long the path is, so you end up adding 2 bits of state. Or you pop this and you hop everyone down, which, because it's all sequential data, it can do fast, but I don't know. It's more complicating, right? That you have to keep doing these updates. So this kind of, what do you call it? I guess it's stack that I'm doing, right? I'm pushing things onto the stack and then I'm popping them off from the same end. Work quite neatly for this, at least for now. So I think that probably stays. Let me just go check the README in case I've missed anything. Aha! We can call that done now. That's nice. Obviously, lots of stuff left to do. I don't know if this is triggered yet, but we've got a rendering bug that's been around forever that I think it's probably time to go and fix. So that's a to-do for next time. In my notes, I'm using a temporary allocator now. I basically t-print in the Odin standard library. I stumbled across it and was like, that makes life way easier than what I've been doing. So I think it just uses an arena buffer, and then you can clear that each frame. So you can allocate relatively small amounts of memory quickly without having to go via the operating system and request memory to page in. So that's a small quality of life thing. Yeah, it's me just working it out. This is what I've been saying, right? This took me a while to work out, and it doesn't quite do everything that I would like it to do yet. And then yeah, I guess to finish on, I think this chunk of logic, I guess I'll call it, like this part of the code base works, but I don't think I've done it particularly neatly. But when I look through it, I can't put my finger on exactly what it is. And I think what's happened is I started working on it without a very clear picture of where I was going. I've ended up kind of stumbling through and just kind of putzing it together. It's not that much code, and it's not that complicated a system. I think what I'm going to do is make a branch that's reverted back to, I guess, before I started the animation work. I might start calling it cross-frame action work. Because animation means something different in my head, at least. But I think now I've got a much clearer idea in my head of what I'm doing. I think, even if I land in essentially the same solution, I think I'll have a better mental map of how it's all working, which will help reason about things as we hit bugs. So, yeah, if I get a free probably hour or 2 at some point, I might do that. This last week, I haven't really gotten that. I've had a very broken up week. So if we have more very broken up weeks, I think we just keep stumbling forward. So I think restarting it to then write it in a very broken up way again is just a waste of time. But hey, such is life, right? This is the problem of having a full-time job, having a family, having all these, like, it's currently the Football World Cup, so we're all watching the football. There's a lot of other things fighting for your time. It's a problem with doing side projects, but I think we're still plodding along. Yeah. I've also been thinking at some point I probably do want. I think we're not actually that far off of the core sort of UI working the way I want it to. So at some point I'm gonna have to sit down and think more concretely about what like the first set of game mechanics really look like. Currently, if I click on you, you just lose 1 health. is the way combat works, which isn't great. So I think probably in a video coming soon, we'll have to run through like these are what the enemies I want to implement are. This is how combat's going to work. Maybe I've just done it because I don't think that should be particularly like engineering difficult. I think it's just I don't know. I've not done any game design, so maybe that'll take me more time than I think. But exciting, we're nearly there. So yeah, I hope you've enjoyed. As always, happy to take any comments or questions down below. And yeah, I'll catch you on the next one. Have a good one.